Today I'll be using calculus to find the centripetal acceleration formula. So let's begin. So let's say an object is moving like this, x, y. And let's say the particle starts here. Now, I want to find a function that gives me the position of the x value with respect to time. So let's say the particle is here, and it's at some x here, and theta. I want it so that if I know the time, I'm also given the position of the x value. Well, we know that the particle has a constant tangential velocity. So v is constant. So that means the formula could be this. And I'll explain what the formula means later. All right, so big T represents the period, or the amount of time that the particle needs to travel to complete one full revolution. And so if we're in, let me preface this by saying we're in radian mode here. So 2 pi represents the total circumference, the full circle. And T over T represents, at a given time, what portion of the circle you traversed. So let's say small t is the time. Like, if we want to find a function that if we know the time, we also know the position. It's not big T. Big T is the period. So if like t equal t over 2, then, well, that's just half of a circle, because that's half of the period, because it takes the full period to traverse the whole circle, right? So if you're only given half the time, you're only going to travel half of the circle. And likewise, if you're given t of 4, you're only going to travel 1/4 of the circle. And yeah, this is the portion of the circle, and 2 pi represents the full circle. So let me just give an example. Let's say we're given that it's at t over 8. Well, if you plug in t over 8 in the formula, inside here we get t over 8 over t times 2 pi, which equals pi over 4, because the big t's cancel out. And t over 8 is, well, that's an eighth of the period. So if we split this circle into eighths, that's 1/8. Yep, it would be somewhere around here. That's like 45 degrees. So in pi over 4 is also 45 degrees. All right. Now, let's find the derivative of this function. The derivative of p of x equals the velocity function, and the derivative of v of x is the acceleration function. We want to take a double derivative so we can get to this acceleration function, because ax squared plus ay squared equals, well, the actual acceleration squared, because we're only taking into account the components here. The components squared and summed together give you the actual magnitude. All right, so the derivative of p of x is just v of x, which equals r cos, r negative r sine t over t, 2 pi, and apply chain rule, 2 pi over t. Remember, big T is constant because the velocity is constant. So if the velocity is constant, the period is constant. And Vy would look really similar. R cos t of t, 2 pi over t. If we take a second derivative, well, this just becomes cos again. And we have to apply chain rule again. And if we do that, we just get 4 pi squared over t squared. And ay would also look really similar. 4 pi squared. It's getting cramped here. Now, we want to square ax squared and ay squared to find the magnitude of a squared. So a would actually equal the root of this squared and that squared. So this is gonna take a long time to write. So a would equal root r squared. I'm just gonna go ahead and factor 4 pi squared t squared and r, or never mind, I'm just gonna do the whole thing and not be lazy. Times cos squared. The negative sign gets removed because if you square something, it would become positive. Alright, and now I'm going to factor out r squared times this here. And if you notice here, well, cos squared theta plus sine squared theta equals 1. So this entire term right here just cancels down to 1. The t is also included in the square root. And finally we get this, r times 4 pi squared over t squared. Now, we want to get rid of this t. We want acceleration, the centripetal acceleration, to be in terms of v and r. Well, this is also an identity. 2 pi over r over t, or 2 pi r over t equals velocity. 2 pi r represents the circumference of the circle. The period t is the total time it takes for it to complete one revolution. So 2 pi r over t would equal the constant tangential velocity. Or like, you can just stretch the circumference into a line, and that's the total distance over the total time period would get you the velocity. So that means t equal 2 pi r over v. And if you plug in t into here, you get 4 pi squared r squared over v squared. Well, the 4's cancel out, the pi squareds cancel out, one of the r cancels out, and the v squared goes all the way to the top. V squared over r. And there you have it. This is a calculus proof. Thank you. Wait, yeah, this is the entire thing.